Okay, now there are a couple of rules that we can understand in terms of the graph of the logarithm function and the fact that the logarithm function is inverse to the exponential function. The two rules are this: b to the x equals c is totally equivalent to x equals log base b of c. That's just the inverse relationship, the inverse function relationship. That's exactly what has to happen if you get the log base b function by reversing the columns of the b to the x function. So, that's a rule. And if we had more time, we would develop these rules in a little more detail. Okay, now log base b of c, okay, if we got a log base b of c, how are we going to calculate that? Well, we don't really have a good way to do it. We can always do it with a calculator. And we could always approximate it with a graph. And I'm going to ask you to do a little of both. Okay? Log base b of c on your calculator, you've got a log button. You just take the log of c, divide by the log of b, and there you have it. Or if you want, you can use the natural log button. Okay? Natural log is a log base e. And you want to kind of remember that. And there's also another way you could do this. You could use log base 2 of c divided by log base 2 of b. And since you know how to make the graph of the log base 2, you could always estimate log base 2 of c, log base 2 of b, and that would give you log base b of c. Again, there are reasons that are not that difficult to understand on the graph, but we're probably not going to have time to go into them. Okay, so let's say we want to solve the equation 2 to the x equals 3. You can use all the algebra in the world that you get before you get into a trig analysis course, and you're not going to be able to solve that. You're not going to be able to rearrange it because x is up here in the numerator. So multiplying both sides by the same thing, adding, subtracting, same thing on both sides, raising both sides to a power, none of that is going to help. Okay? What you have to do is you have to use this. You have to convert this to a statement, to an equation involving the log. This is equivalent by the first rule to what? Well, your base b is 2, that's your b, x is your numerator, your exponent, and c is equal to 3. So we can translate it into this. X is x, b is your base, remember that was 2 up here in this expression. So x is log base 2 of c, which is 3. Now, you could get the log base 2 of 3 easily. I chose a convenient base because we know this graph and we know the graph of its inverse function, the base 2 log. So we could go to the base 2 log, sketch that graph, find 3 out here, project over. Now I know if it were at 2, this has to be at 1, so that looks like it's maybe 1.5 or something. Now if you had an accurate graph, I've asked you to do estimates with that graph, you know how to do that. So you already know how to estimate a solution to this equation. But of course, you can go to your calculator. And it's log of 3 divided by log of 2. Okay, so log of 3 divided by log of 2, or if you prefer natural log of 3 over natural log of 2, your calculator doesn't have a log base 2 button. Log base 2 is helpful if you want to see how it works out graphically, and it's always important to do that for a depth of knowledge. Okay, but just after the solution, there it is. You can take your calculator and work that out. I'm going to ask you to do that for homework. And then check. Plug that into the equation 2 to the x equals 3, your value of x, and use your calculator to see if it comes out. Now there are additional rules of logarithms, but we're not going to use them in this course. These are enough to solve the logarithmic equations we need to solve for finance, and that's where we're headed. And again, as I've said, finance kind of illuminates populations, epidemics, radioactive decay, everything else. We're doing it in terms of finance because that's in part of the course description. We're supposed to do that, and it's very useful, very important. Okay, there you have it. Now we're going to do a couple more slightly more complicated examples, but they're not going to be any more difficult really.